Okay, today we're going to be working on what we call combinations of functions. Okay, we're going to talk about 5 ways to combine functions together. Okay, we cannot combine functions unless they have overlapping domains. If they have nothing in common, we can't do anything with them. Okay, you're never going to see that. Anytime I give you 2 functions to combine, they're always going to have overlapping domains. Okay, so the first way we can combine functions is by adding them together. Here's the notation. If I ask for f of g of x, that just means add the 2 functions together. We can also take the difference of 2 functions. Now, what am I going to tell you to be careful with when you take the difference? Same thing I told you yesterday when I was talking about common quiz mistakes. When you subtract your second function, what do you need to do? Okay, it would be a wise idea to put that second function in parentheses because this subtraction has to be carried throughout the entire function. Okay, that was a common mistake on your quiz on 9C, is that we didn't subtract the entire function. Some people just subtract the first term. Okay, so either carry the subtraction through g of x or put g of x in parentheses so you remember to carry it through. Okay, but please be careful. That is a mistake that is completely avoidable, okay? We can take the product of 2 functions. We multiply them together. And what do you think the 4th one's going to be? You don't think division? Oh. What's it called? What's division called? Taking the quotients. Okay? When we take the quotient, we do have to be careful. We cannot divide by 0, so we just need to make sure that g is not going to equal 0. Is that better? So, we're going to take 2 functions and we're going to do these 4 operations with them. Okay? Here are our 2 functions. What kind of functions are both of these? Linear, which means since they both have slope and they're linear, or they both have non-zero slope. What is their domain? What's the domain of a line that is not vertical? Yeah, it's all real numbers. Okay? The only time we don't have all real numbers on a line is if we have undefined slope and we have a vertical line. Okay? Any other line has all real numbers for a domain. Right? It goes on forever in both directions. So first, let's take the sum. Okay, what was the point of me talking about their domains? Their domains are actually the same, which is nice, but they overlap, so it is possible to combine our functions. So let's take our sum, f plus g of x. So we have 2x minus 5 plus 2 minus x. What is our resulting function? X minus 3. Okay. Anytime I ask you to combine functions, I will ask you the domain of that result. So what is the domain of x minus 3? Yep. It is a linear function, so it's going to have all real numbers for a domain. Okay? I would like it in interval notation. Okay? Did everybody hear his question? Okay, I don't want the R anymore. I want the interval notation, negative infinity to infinity. Okay? All right, the difference of two functions, so f minus g of x, we're going to take 2x minus 5, and we're subtracting the entire g function. So please put it in parentheses. Okay? What is our resulting function? Yell it out. Careful. Because we have 2x minus a negative x gives us 3x minus 7. Now, if you need to rewrite this, if you need to distribute that negative through and rewrite it all and then combine like terms, go for it. If you can think about it in your head, go for it. We're past algebra 1, we're past algebra 2. I will let you decide what you need to do with that in order to help you. If you have problems forgetting to do that negative through in your head, then write it out. Okay? What's the domain of our resulting function? What kind of function is it? Linear. So what's its domain? All real numbers, because we don't have an undefined slope. All right, our product. We are taking 2x minus 5, and we're multiplying it by 2 minus x. Now, since both of these have more than one term, you're going to need to put those in parentheses. Okay? Really, anytime you have multiplication with functions, put it in parentheses whether there's one term or more. Okay? All right, so what are we going to have to do? Opposite of factor. Okay? We're going to have to distribute. You guys like to call it FOIL, right? So what's the product of our first? Outside? Negative though, correct? Inside? Last? Okay, now I'm kind of picky. When you combine like terms, please put them in order, like you would see them in a function. So from highest degree to lowest degree. So I want negative 2x squared to be first, 4x plus 5x is 9x, and then minus 10. Please organize them in order. Now, what kind of function is that? Quadratic. Good. What's its graph going to be? It's a quadratic function. We get a parabola. What's the domain of any parabola? What's the domain of any parabola? You're thinking the range. Domain, it goes on forever to the left, it goes on forever to the right. All real numbers. Any polynomial, linear, quadratic, cubic, quartic, they're all going to have domains of all real numbers. So if it's polynomial, it's going to have a domain of all real numbers. Yes?
What's an example of one that wasn't quadratic?
Oh, that's a great question. Let's look at the quotient. Okay, our quotient is going to be f divided by g. Can we simplify that at all? No, we cannot. Okay, so we're going to leave it like this. But why is this domain not all real numbers? Okay. We have a fraction, which means we know we cannot divide by 0. What makes our denominator 0? 2. So our domain is everything except 2. So remember we talked about how to write this yesterday. So from negative infinity until 2, and then from 2 to infinity. But we can't include 2, so we put those parentheses around it. Okay? Okay, so just because both, that's not what I wanted to know. Just because both of our functions were all real numbers, that doesn't mean that that's going to be our domain for all of our combinations. Okay? So just each time you take a combination, look at the resulting function. If it's polynomial, all real numbers. If it's rational like this, we need to look at the denominator. What else did we look at yesterday that had a restriction on the domain? What was the other function we looked at yesterday? We had a fraction, and then we had a radical, right? What kind of numbers can't be under a radical? Negative. Okay, so that's something that you're going to have to look for too. Okay, I can't remember if one pops up on your homework tonight or if it's tomorrow, but those are the two big things that we'll have to look for, if it's a fraction or if it's a square root. Okay? Now, let's talk about the composition. Okay, this is, I told you there was 5 ways to combine functions. Here is the 5th way, probably the most important. You'll probably see more of these problems than the other ones. Okay, you've done the composition of functions, okay, where you put a function inside of another function. You are probably used to this notation. You've seen that before, correct? Have you seen this notation right here? The F composed with G. Okay, it means the same thing. When you see this F, open circle G, it means F of G of X. Okay. Okay, so know that these two notations mean the same. If you see this and you want to write it as this, that is fine. Now you worked on composition of functions in Algebra 2. Whether you remember it or not, you did. Okay? So you've seen this before. What we're going to be concerned about here is performing the operation, but also the domain. Okay, well, you haven't talked about the domain. All right. So when we talk about the domain of a composition function, okay, we have to be careful because we're putting a function into a function. All right. So the domain is the set of all x in G, such that G of x is the domain of f. Okay, look, what does that mean? All right. We are putting values into our function G. Okay, so the first thing we're going to be concerned about is the domain of G. All right. If that's restricted, okay, if it's not all real numbers, okay, that's fine, but we're just starting out with whatever domain we're plugging into our function, okay? We're going to get something, we're going to get an equation here, okay? Maybe it's polynomial, maybe it's rational, maybe it's, who knows what it's going to be, okay? Whatever our domain is here with this equation, we have to look at where this domain overlaps with our resulting domain, okay? If g of x that we're plugging in is not all real numbers, okay, then our results cannot be all real numbers because we have to plug things into g before we can plug them into f, okay? It might not make sense until we see an example, just like some things that we do in math, okay? So if this is going over your head, don't panic because we're going to talk about it with an example, okay? But basically, we have to look at the domain that we're plugging in and compare it to the domain of what we get at the end and see where those two overlap. Okay. All right, so we're going to do an example, but I'm changing my functions from before. Okay. So here are two functions. Go ahead and write them down. Okay, so we are going to find f composed with g. All that means is f of g of x. Always start from the inside out. This may help you with one of your quiz corrections on your assignment. Okay. So we're going to start on the inside. Inside we have g of x, which is the square root of 9 minus x squared. Right? Okay. Then we're going to evaluate f at the square root of 9 minus x squared. So f is x squared minus 9. But instead of x, we're replacing it with whatever is inside the parentheses. Okay? Notice how I put it in parentheses. Anytime you substitute, I think I've said this about 10 times now this week. Anytime you substitute in parentheses. Okay? Not always is it necessary, but when it is, I don't want you to forget. Okay? So what happens here? We have the square root of 9 minus x all squared.
Does the x inside the parentheses need to be squared too?
Oh, thank you. Yep. I didn't get that transferred. Thanks. Okay, so what happens with this square root being squared? Okay, it goes away. So we have these cancel. We have 9 minus x squared minus 9.
Wait, the minus 9.
Because our f function is x squared minus 9. Okay. All right, so what do we get? Negative x squared.
So you just plug in g of x for whatever the x is in the f of x function.
Yes. Okay. Now we need to find the domain. Okay. So the first thing we're worried about is we plugged in g of x to our function. Okay. Well, what numbers can we even plug into g of x? Because that matters. So we need to find the domain of g of x. Okay, what kind of function is g of x? It has a what? And it has a square root, right? And what do we know about the domain for any square root? Whatever's underneath can't be negative. Okay, so 9 minus x squared has to be bigger than or equal to 0, right? Okay. What? Okay, well, do you have it? It can't be any bigger than 3? Okay. Is there any other restriction? Bigger than 3? Because if we solve this out, 9 minus x squared, if we solve that out, we're going to get x is 3 or negative 3, correct? So Noah's saying it can't be bigger than 3. Is there anything with the negative 3? Can't be smaller than -3, right? If I put in -4, you're gonna get an imaginary number, right? So our domain, it can't be bigger than 3, it can't be smaller than -3. So we're between -3 and 3. But we can have the square root of 0, so 3 and -3 are okay. Okay? So this is what we're already restricted to. This is what we can plug into G. Now we need to look at the domain of the result. Okay? What do I mean by the domain of the result? This is what we got when we combined our functions. So I'm looking at the domain of -x squared. What's the domain of -x squared, just as a solo function? All real numbers. Okay? So where do these two domains overlap? Where do they have numbers in common? Okay. Since this is all real numbers, it's easy, right? They overlap here. So the domain of F composed with G is where these two overlap. Okay? -x squared, just all by itself, has a domain of all real numbers, but since that's what we got as a composition, we can only plug in from -3 to 3. The composition of the two is restricted. Okay? You learned one new thing today. You learned how to find the domain of the composition. Otherwise, everything else you've seen before, right? Okay. Here's our assignment. You have time left in class, so you can either start this assignment or work on quiz corrections. I don't care. When are quiz corrections due? Tomorrow. When is your 8 basic function chart due? Thursday. There's already a key online for you to start checking. Okay.